Hey guys, I'm Rohit, and today we are going to be doing Notes 2.1a Forces. Now, this is for physics. If you're in biology, you're obviously in the wrong video, but a lot of you will be here for physics. So he gave us this note packet, and he didn't really say what we're going to do, but there are some practice problems inside of here. So I'm just going to go over the notes quickly, and then we can go over the practice problems and see how we can do them. Now, the entire aspect of this is on forces, so let's say we have something here, pulling over here, pulling over here. The force on this object. Now this is pretty strong, so this won't break, but this is metal. So that's pretty strong resistance to forces. Now here you can see an astronaut pulling here 60 newtons, 50 newtons, so that a resultant is going to go 10 newtons this way. Makes pretty much sense, it's basic addition, subtraction. Here, you have to find the hypotenuse of it. It's going 50 newtons this way, 60 newtons this way, so you have to find x. Pretty much the same thing. Now, the fact that this goes away. Now, yours wouldn't be in color. Mine is in color because I just printed out a new one for you guys. Yours is probably going to look black and white like this, but without after this. So, let's start off with practice 1A. Now, find the resultant force. So when we draw a force diagram, it will be a point. Let's zoom in here because we're only focusing on this. It will be a point. Now it's going down 10 and it's going up 10 newtons. And it's going to the right 10 newtons as well. You can see that the top and the bottom, they cancel out. So we're just left with this 10 newtons this way. So we'll just write here the resulting force is 10 newtons. Whoops, I just broke. There you go. That's the answer for 1A. Pretty simple. Now, for 1B, we have 40 newtons on this side, 60 newtons on this side, and 40 up there. Now we can do simple subtraction. So 40 minus 60. What's 40 minus 60? We don't need a calculator. It's just 20 newtons. So if we draw a point, is it going to go this way or is it going to go this way? That's the thing. So you want to go with the bigger thing. Imagine it as like 4 dots over here. So 1, 2, 3, 4 over here and 6 over here. Then you use up all of these 3, but you only use up 4 of these. Oh, sorry, 4 of these. 4 of these. You still have 2 left over here, right? So you have a point, and you're still going to the right 20 newtons. That's still there because this was 60 newtons to begin with. This is 20 newtons left. Now it's still going up 40 newtons, so we can't throw that away from here. So it's going up 40 and to the right 20. Now we can't have 2 vectors. We have to have one just like we had here. So we have to find the hypotenuse of these. So let's remake this triangle. Up 40 to the right 20. And we had to find this. So we bring in our calculator. It's on 40 squared plus 20 squared equals, and then we take the square root of this. Square root of 2000 is, and then he wants us to have 3 significant figures, so 44.7. 44.7. Now, we don't just need this, we also need an angle. Now the way we find out the angle is with the inverse tan. So the inverse tan of the opposite over the adjacent. So we look over here, what angle do we want? We want this angle, right? So what's opposite this angle? 20. Right across, this is opposite. And what's adjacent? What's right next to it? 40. 40 is right next to it. So it would be the inverse tan of 20 over 40. So let's see. Oh, also, if you don't know where the inverse tan button is, it's second and then it's just tan. Second and tan. And then to do, you go set alpha, y equals enter to have a fraction bar on your calculator. So the opposite is 20 4, 2 divided by 4, 26.5. 26.6. 3 significant figures. So this is at 26.6 degrees. Now let's simplify this. Just make it look nicer. So a point roughly going this way. And this is going this way at 44.7. And the angle, what's the angle? 26.6. 26.6 degrees. There you go. That's the answer to 1B. Let's do it over here again so you can see. It doesn't hurt. So the magnitude of this angle, 26.6. No, this is the angle, 26.6 degrees. And this would be 44.7. Nice. Alright, 1C. Pretty simple again. So we're going 3 up, 5 to the right. We're trying to find this hypotenuse. 3 squared plus 5 squared. Oh, 3 squared plus 5 squared. And we take the square root of 34, and we get 5.83. So 5.83. We draw a little thing there. And now we do the inverse tan of the opposite angle. We're trying to find this angle, correct? So the opposite would be 5. Opposite is 5. And what's right next to it? The 3 is right next to it. So 5 over 3, and we get 59.0. So this is at 59.0 degrees. There you go. Now this is where it kind of gets tricky when you have two angles like this, but it's simple if we break it down. So let's just take a piece of paper and let's do it on there because we're gonna run out of room. Here, watch this. Ready? 3, 2, 1. Whoa! You see that? The problem is just got traveled here. Amazing, isn't it? Okay, so there's not enough space on the paper, so I'll just do it here for you. Now, this is the problem. We have to find the resulting of this. Now, whenever you have something diagonal like this, you want to find the resulting vectors up and horizontally. So we have to break this up into its component parts. This is the hypotenuse. We want the legs of the triangle. So that's pretty easy. We just have to use so, ka, toa. Now, I know that sine of the angle, so sine of theta, is equal to the opposite over the hypotenuse. Now, the theta is just 20. The opposite, that's what we're trying to find. So this would be the opposite. So let's draw this triangle over here so we can more easily see it. This would be our 50, or our hypotenuse. Right here would be our angle of 20. And this is what we're trying to find here. This angle, and this, not an angle, it's called a magnitude. So the magnitude up and the magnitude to the left. This is the hypotenuse, this is the opposite, this is the adjacent. So when you use sine, we're finding this one right here. So the sine of 20. Sine of 20 is equal to the opposite of the hypotenuse. The hypotenuse is 50, so multiply by 50 equals the opposite. So let's take our calculators. 50 times the sine of 20, and we get 17.1. So this going up is 17.1 newtons. Now, if you want to find the adjacent one, you can do this entire thing again by putting sine, by finding out that it's cosine. But all you gotta do is just replace sine with cosine, and you'll get the adjacent. So just write 50 times the cosine of 20 equals the adjacent. Let's go back to your calculators, go up, enter, and then replace with cosine. And then you get 47.0. three significant figures again. 47.0. Now filling it into the big one. So we know that from this point, it's going up using this formula. 17.1 newtons. 17.1 newtons, and it's going down 17.1 newtons. Right? And then it's going to the left 47.0 newtons. You can see that I was trying to calculate this, and I also use it for the bottom. If the angles are the same, 20/20, and the magnitudes 50/50, you'll know that they're just the inverse. So you're basically doing the same thing here. You're just looking for the magnitude down and to the left, right? So you can save yourself a lot of work. Well, it's not a lot of work. You're just doing the same thing. So it's going down and up. Now, when you're going to the left, for the top one, you're going to the left at 47.0 newtons. I mean, not newtons. Yeah, newtons. 47.0 newtons. That's for the top. But you're also going 47 newtons to the left with the bottom as well. So you're adding this one and this one. So it's just going to be 2. Just like that. Don't forget to do that, because a lot of people do. Remember, you're taking into consideration both of these vectors. Not just the top, not just the bottom, both of them. That's why you have this goes with this, this goes with this. Now, if you simplify all of this down into one point graph, so here, one going up, one going down, one going to the right, one going to the left. If we look here, this will just be 17, this will be 17.1, same thing. This one would be right here 20, and then this would be 47 times 2. Quickly do that on the side with my calculator. 94. These are all newtons, but you understand. So the top and the bottom, these vectors cancel out because they're equalizing. They're both pulling at the same time, so it's not moving. But these, you're going to have to subtract. So what's 94 minus 20? Oh, it's just 74. So, and this will cancel out because 20 is less than 94, so it will be going 74 newtons to the left. Now if it's just left, you can just leave it like this, and through all of this work, that's your answer. You don't have to put an angle here because it's just straight to the left. And take a paper back, straight, 74 newtons. There you go. Now let's go on to the next page. Now this is 1, 2, 3, 4, 5, 6. These are 6 problems. I'm going to go through each of them, alright, except for 3A. I personally do not know how to do 3A. I know, tragic. I'm not perfect. I emailed Miss Putnam. He said just come back to me, talk to me tomorrow. If you can I encourage you, I challenge you to do 3A, because I can't figure it out. I know at least one of you know how to do this, and if you do, come talk to me. Tell me. I actually want to know. This channel isn't just for you guys to learn, it's for me to learn as well. I want to know how to do this because I'm trying to get in advanced as well. Alright, anyway, enough about me. Let's start. So 2A, find the force required to balance the forces. So now we're not trying to find the resulting factor or what happens overall to the graph. We're trying to find out the resulting, or what we need to balance the forces. So this 60 and this 60, they're already balanced. As you can see, they're the same. But this 40 and something, we have to try to put, what are we trying to put here? So they have to be equal to the top, right? So if there's 40 newtons pulling from the top, what has to be on the bottom as well? 40 newtons. So the force must be equal to 40 newtons to balance the forces. Pretty simple. Now, 2B. That's basically what we're going to do here. But what we're going to have to do is separate these vectors into their vertical components and their horizontal components. Now, we got a lucky break because we just need to find one of these because they're both the same. 30 degrees, 40 newtons. So, using the magic. As you can see, there's nothing on my screen. 3, 2, 1. Whoa. See that? It's transferred on. Magic. Okay. So, I just put it on here so we can see the work more easily. Horizontal components, vertical components. Alright. So, ka, toa. More and more, I feel like this is a trigonometry class, honestly. So, when you're using sine, you're trying to find the opposite vector. So let's take this angle and let's rewrite it into a right triangle. So 40 would be here, 30 would be here. So when we use sine, we're trying to find the opposite. So that'll be the horizontal component of this, because we're trying to find this. So the sine of 30 equals the opposite over the hypotenuse. We already know the hypotenuse is 40, so we just multiply by 40 to get on 40 times the sine of 30, 20. So the horizontal component for this is 20. Now, we don't need to do this entire thing again. Let's go back on our calculator and type in cosine. And we get, for the vertical component, because it's cosine and it's adjacent, 34.6. And again, if you don't feel comfortable just switching it up like this, you don't have to. Because sooner or later you might not get the exact same answer as I do because of the relative, differences. So if you want to do the entire thing of the SOHCAHTOA and do the cosine, you can. But I just know that the adjacent will just flip it from a sine to a cosine. So for this angle, we know that the vertical component is 20, and because it's the same, the angles are the same. Always check. 30, 30, 40, 40, they're the same. So it'll also be going to the right 20. And then it will be going up with the vertical component, 34.6. 34.6. One from this side, one from this side. Don't forget to double it up. 34.6. Now let's just simplify these into one point graph. So it's going up 34.6 times 2, which should equal 69.2. 69.2 newtons. It's going down. That's what we're trying to find. We're trying to find the downforce, what it should be. It's going to the right 20. It's going to the left 20, 20, 20. These balance out. We don't need to do anything here. So in order to balance this out, what does F need to be? It needs to be the same as the top, 69.2. So what does F equal? F should equal 69.2 newtons. After simplifying these, pretty simple to know. Alright, again, like I said, this has stumped me. But it might not stump you guys. I'm guessing it's in equilibrium because the others aren't in equilibrium. But, again, correct me if I'm wrong. So let's skip 3A, go straight to 3B. Let's look at the examples. By resolving the vectors into components, calculate if the following bodies are in translation equilibrium. So if they're equal, or if they're not equal, put them into their resulting forces. So like we did in the other one, where we had to find these, the resulting forces, basically those, if they're not in equilibrium. So let's do this right quick. Now, again, there's nothing here, correct? Absolutely nothing here. We just gotta take our thing. 3, 2, 1. Oh. There it is. Magic. Okay. Oh, dude, this is fun. So, let's try to find the resulting factors. You see these curved things. Find the horizontal component, vertical component. Alright, now sadly, these are not the same. The magnitudes are different as well as the angles. So we're going to have to do each of these differently. It shouldn't be that hard to go. Again, write your SOHCAHTOA if you need it. Good. If you don't need it, amazing. So let's take this angle and let's rewrite it so it's easier for us to know what we're talking about. this would be our 6, and this would be our 60. So if we're trying to find our horizontal component and our vertical components, the opposite, so the sine, and what's our theta? Sine of 60 equals opposite over hypotenuse. Hypotenuse, what's our hypotenuse? 6. 6 times the sine of 60. Take out the calculators. 6 times the sine of 60. We get 5.19, rounding to 3 significant figures, 5.20. 5.20, vertical component, opposite. Now adjacent, again, flip to cosine, and we get 3. Wow, that's nice. Don't you just love it when they're whole numbers? 3. So for one of these angles, one of these, vertical component is 3, and it's going to the right, 5.2 newtons. 5.20 newtons. Now we have to do the same thing to the other side. Now let's draw out this right triangle. Oh, I did backwards. Do you think? Nah, you guys can just. Nah, I'll redo it for you. So the hypotenuse is on this side, just like that. 4, and the sine is 30 degrees. Always draw it just like it is, otherwise you'll get super confused. So the sine of 30, because that's our theta, is equal to the opposite of a hypotenuse. In this case, our hypotenuse is 4. 4 times the sine of 30. 4 times the sine of 30. We get 2. So we're trying to find the opposite. This was our opposite. Opposite vector is 2 newtons. Now let's try to find our vertical vector, which just replacing the sine into the cosine. Oh, sorry. Cosine. 3.46. That crazy mess. So let's see, how would we, it would be 3.46. That's it. So going up, 3.46. Now let's write that down here. So what was our vertical component again? Oh, nice, it's just 2. And then going vertical, oh sorry, vertical. 3.46. Guess what we got? We got a 3, 3.46, 5.2, and a 2, and a 4. Don't forget about the one that they gave us already. So let's write this down in a simplified version. Sorry if it was crooked. It's going up. 3 plus 3.6 is 6.46. It's going down 4. That's straight, believe me. It's going to the right, 5.2, and to the left 2. Now subtracting the graders from the smaller, so 4 minus 4.6, so it will be going up 2.46, and then the graders, so it will be this way, so 2 minus 5.2, 2 minus 5.2 is 3.20 newtons. So it's going up 2.46 newtons, and it's going to the right 3.20 newtons. After we simplify these down, subtracting. And now we can't just have 2 like this, because our end goal, we're trying to find our resultant force. So we have to combine these. This is just another simple triangle. If we rewrite this, 2.46 and then 3.2, and we're finding our hypotenuse, it's just d squared. 2.46 squared plus 3.20 squared. Square root of this, and we get 4.03, 4.04. And that's our magnitude. And we're not done. Don't forget the angle. Never forget the angle, because he will copy you. He will take off points, he will murder you, and it will be horrible. So, but it's really simple. The inverse tan of the opposite over the adjacent. What is the, so we're trying to find this angle, correct? What's the opposite to this? 3.2. What's next to it? 2.46. Just write 3.2 and then 2.46. Right there. Simple. Second alpha, not second alpha, second tan alpha y equals, enter to get that fraction boy, 3.2 and then 2.46. Enter. There you go. 52.4. So this is at 52.4 degrees. Nice. That's what I got in my answer sheet. Actually, this is me pulling here. Okay, so let's write that down on our equation right here. Big fat circle. Our magnitude vector, the magnitude of the vector is 4.04 newtons, and our angle for this vector is, you see, I almost did a fat L here. So you see, we calculated the vector for this, correct? Let me zoom in so you can see more clearly. We calculated the angle, this angle. This angle and this angle is not the same thing, as you can see. That's basically saying this angle right here versus this angle right here. I calculate this vector at 52.4. So remember that. Don't forget that. I already wrote this down, but let's go like that. And this is 52.4 degrees. If you want to find this to like level, if you're really one of those people, just subtract this from 90. So subtract that from 90 and I get 37.5 40.6 if you're rounding degrees here. But I believe this is simpler, so just leave it like that. Good. Turn the page here for our scratch work. And let's go on to 4A. And zoom out so you guys can actually see what we're doing. 4A. Read the directions. If the following bodies are in an equilibrium, calculate the unknown forces. Okay, so if these are in equilibrium, calculate the unknown forces. Basically what we did on the first two. Up here. Hey, that's pretty good. These angles are the same, these magnitudes are the same, so we just need to calculate one of them, and we already got it. Wait a minute. That's not parallel. Remember how we have the horizontal vector? We have the horizontal vector and the vertical vector. We're trying to find the angle in between these vectors, right? So all we're trying to find is this, because we want to make this equal. So we're trying to find the opposite of f of 1, so we know what f should equal to make it an equilibrium. So let's just find this out. Let's just try it. Ready? You can see, let's zoom out to make it even more dramatic. Ready? 3, 2, 1. That was a fail, wasn't it? But you know what? We don't care, because after all, look, it's already there. No cuts at all. There it is. It's kind of off center, but you know what? That's fine. Alright, so let's take this angle. That's our angle right there. So we have our leg. We have an angle. We don't know anything else. So we don't have our hypotenuse or our opposite. We have our adjacent though. So we can still find out what this is from our adjacent using normal SOHCAHTOA. Now let's see. SOHCAHTOA. We have the adjacent, so let's write cosine. So the cosine of 45 is equal to the adjacent over the hypotenuse. So the cosine of 45 is equal to the adjacent, which is what we're trying to find, no, what we have, we already have the adjacent, which is 6, over the hypotenuse. So multiply by the hypotenuse. So our h times our cosine of 45, sorry, equals 6. Divide by cosine of 6, cosine of 45, cosine of 45, to get our h by itself. So 6 divided by the cosine of 45. And using our calculators, we get alpha y equals second, 6 divided by 8.48, 8.49. Significant figures. That's what this h equals. Now, we could do the exact same here, but it's the same. So here will be 8.48, 8.49, and then using the other angle will be 8.49. So just times that by 2, get 17.0. So using a resulting angle, 17.0, and then what would our f be? F of 1? 17.0 as well. Now a lot of you might think, oh, that's simple. Just take the hypotenuse of this, right? Because look, it's an angle. Just take the hypotenuse, we'll be all good. No. Because if you do that, you'll just be finding this. And that doesn't tell you anything. Here, let's just do it quick, right? 6 squared plus 6 squared is 72. The square root of 72 is our answer. Nah, I'm just kidding. I knew it from the beginning. You could do it that way, and that's simple as well. But I want you to know the concept of it. Anyone who's skipping to this point in time will know what that means. But yeah, you can also get the answer. But understand it. It's the opposite. So let's say you're going x this way, same. Take the hypotenuse of it. Really simplified version. Take this. 6 squared plus 6 squared equals 72. Square root of 72 equals 8.485. 8.49. That's your answer. But that's just for one, so you have to add another 8.49 because that's only one of them. So yeah, it's really tricky if you do it this way. I suggest doing it this way, because then you know one angle, another angle, to get two of the 8.48s. Alright, even though you get the direct answer this way, you still have to know it. So, yeah, 8.48 plus 8.48, 17.0. The answer is 17.0, nevertheless. Okay, next, what we have here is 4b. Now, 4b looks super tricky because it's not on the axis, it's not on the center of mass, it's somewhere over here, right? And that can be kind of confusing because like, whoa, wait, hold on, this is different from everything else I've done. No, it's not. You've seen this. It's super simple. I'm actually going to do this on the problem because it kind of get confusing. So using SOHCAHTOA here, if you're trying to find the opposite, so you should know this by heart now. 20 times sine of 30 is 10. So we know the opposite. This will be going up 10 newtons. And then doing the opposite, so instead of sine, it'll be cosine to find the one adjacent to it, 17.3. So now we know it's going this way, 17.3. Now we can apply this to our actual center of mass. So it's going to left 17.3 newtons, and it's going up 10 newtons. 10 newtons, just from this force. Now, in the end, we're trying to find f of 3 and f of 2. So we already know that f of 3 already has 10 newtons pulling on it from this. So whatever we want, so let's, okay, 60 newtons. We want this to match, correct? So intuitively, we would just write 60 here and we'd be done. No, because there's already a 10 newton pulling on here. If you write 60 newtons here, there would be a total of 70 newtons pulling here. So we want 10 less, because you're going to add 10 here from this to whatever we have here. So this would be 50. F of 3 would equal 50 newtons, because you get 10 newtons from here. 10 plus 5, 50 is 60, 60, 60. Totally balanced out. For here, f of 2, you have a 17.3 newtons here. You want to have a 17.3 newtons here. F of 2 equals 17.3 newtons. Wow, that was crazy. Thank you if like some people stuck to this entire thing. This took me quite a bit time to make, and also actually to do the problems too. I spent like basically an hour just trying to figure out 3A. Obviously I didn't figure it out, but still a lot of time. Okay, a lot of people are going to skip to this point too, because I'm going to go over all of the problems really quickly and the answers to them. So thank you for the people who are watching for the explanations. Again, just links are in the description below for the times. And next I'm going to go over the entire thing. Alright, thanks. Yo, what's up? A lot of people are going to be skipping to this moment. This is a super hyper quick overview of everything we went through and the explanations on how I got them. This is the pack that we're doing. Alright, so question number 1A. So we're trying to find this units. 10 newtons up, 10 newtons down. These cancel out and you just have 10 newtons here, 10 newtons to the right. That's our answer. 1B, 4 newtons here, 60 newtons here. 40 minus 60 is 20. 20 to the right, and then our 40 up here. We just find the hypotenuse of this baby, and we get 44.7. Next, we take the angle, and the way we got the angle is using our SOHCAHTOA. We're trying to find our tan of this, so the inverse tan of the opposite over adjacent. So the opposite being 40, adjacent being 20, 2 over 4, inverse tan of a half, 20 over 6. 1C, we're just finding the hypotenuse of this, going up 3, to the right 5, 3, 5. 3 squared plus 5 squared is square root of that, and we get 5.83 newtons. Let's write newtons here. And to find the angle, what we did, we took the inverse tan of the opposite over the adjacent. So 5 is opposite, 3 is adjacent, so we just take the inverse tan of 5 over 3. Next is 1D. This is our answer. Next is 1D. So we had to simplify these, find the horizontal components and the vertical components. The vertical component ended up being a number that canceled out with the other vertical component because they're the same. So 20-20, 50-50, top and bottom is the same, but the side to side ones add up. So just whatever that was minus 20, and we get 74 to the left. 2A. Okay, now we're trying to find what F would equal if they balance. So 60 and 60 on either side, they balance. 40 and 40 on either side, they would balance. So we want to find the opposite. Write that down. So F equals 40 to make the balance. Here we have to find the vertical and the horizontal components of it and find the opposite of that. So using SOHCAHTOA again, finding the opposite and the adjacent, adding the two adjacent together because these are the same. The horizontal cancel out because they would be the same angle, so these cancel out. So we just have to take into consideration the vertical component, and the vertical component equals 69.2 up here, and it has to be the same on the top and the bottom. So F down here would also equal 69.2 newtons. Sorry to all the guys coming here looking for an answer to 3A. I could not find it. I tried so long to find it. I could not. I'm really sorry. If you found the explanation, come up to me. I would really like to know. Alright, 3B. So we had to find the horizontal components of this angle and this angle as well, and the vertical components. So we did that. We found it this way, this way, this way, and this way. They will be different because the angles are different and the magnitudes are different. After doing all of that and comparing it to the 4n, we found out that our horizontal magnitude, our magnitude is 4.04 newtons, and our angle, if regardless where you want it, at the 90-degree mark, 52.4 degrees, or from 0, 39.6 degrees. Really doesn't matter. Almost got it caught up there. Now we also have to find out what f would equal again. So really two ways to work around this. If you see 6 and 6, take the hypotenuse of it. So 6 squared plus 6 squared is 72. So it's square root of 72. And then you do that twice, because that's for one angle, that's for the other. But it's kind of tricky because you don't know where the twice came from. So I suggest using SOHCAHTOA, finding the adjacent using this. And when you do it this way, you would find out that this would be the leg. And alright, so 6, this is the hypotenuse right here, and these are the two legs. So if you find the adjacent for here, you would know that that is the only way that you can figure it out, because you have the hypotenuse, you don't have the adjacent legs. So find the adjacent here, find the adjacent here, add those two together, and you get your answer of 17.0. Next, lastly, for B, it looks tricky because it's not on the center of mass. Find the vertical components of this, 17.3 horizontally, 10 newtons up. Add that to this, so it's going 10 newtons up from the center of mass, 17.3 newtons to the right from the center of mass. So for f of 2, it would just be the opposite of this. I mean, not the opposite, the exact same, because they want them to balance out, 17.3 newtons. But for f of 3, it's a little trickier. You would think that it would be 60-60, but you're already adding a 10 newtons. You're getting 10 newtons of force already from here, so you have to subtract it from this, so it doesn't equal 70. 10 plus 50 is 60, so these cancel out. 60, 60. Now, I hope you guys enjoy. I hope you guys learned something from this. He's probably going to go over this in class. Really looking forward to knowing what 3A is. And if you guys have any questions, let me know either in the comments or when you see me next tomorrow in school. But I don't know. Happy physicsing. See ya.